Hello there everyone, this is KP the Math G, and I'm delighted to present to you this problem. It's a 2021 problem number 5. It's a free response question, and I've been dealing with free response questions for some time now. I love to do them. And if you remember, recall from the last video, and if you don't recall, it's okay. From the last video, we considered, which was the 149th video, by the way. This is going to be the 150th video. Consider the function 2y squared minus 6 equals y sine x. They have already, it says for y greater than 0, dy over dx is y cosine x over 4y minus sine x. One of the questions said, clarify this, make sure this is really true, and I think that's A part. I don't know what all the other parts are, but C part was find this point here. Okay, and I can't remember all the stipulations that went with that one. Let me look. I do have it here, by the way. Sorry about that. Yeah, for 0, x between 0 and pi and y greater than 0, find the coordinates of the point where the line tangent to the curve is horizontal. And we found these 2 points right here, or the 2 points, 1 point at the x and the y is what I'm talking about. Pi over 2, comma 2. So you had to know this one to be able to do this one. So it says determine whether f has a relative min, a relative max, or neither at pi over 2, comma 2, at the point that you found in part C. Alright, well, I love this problem, I really do. It does. The only thing about this problem that's really difficult a little bit is that it is laborious. I'm not saying boring, it's laborious. It takes time, and you have to be precise, or you may miss this problem very easily. Alright, so a relative max. You got to go back to these derivatives. When you talk about taking the first derivative, and by the way, this is the first derivative right here of this function f. This is the first derivative, right? What is the first derivative? What do you find when you're looking for, or what kind of thing are you seeking for in a first derivative? Well, first of all, you might think about relative maxes and relative mins. And you want to hope that dy over dx is equal to what? This slope. What should it be equal to? Absolutely, it should be equal to 0. Why? Because the slope is 0 if there's a max. This is concave down, by the way. Alright, this would be concave down, and this would be a max right here, wouldn't it? So if it's concave down, you have a max, and of course the slope here is equal to 0, right? And if it is a min, you're going to see something concave up. Alright, that's going to be a min. Alright, and then the slope here is going to be, again, 0. Well, we're saying m, or dy over dx, is equal to 0. Well, let's test that theory. I say theory, let's test this. Is this really true? Is that really true? Am I going to be able to erase that question mark? Well, let's find out. Let's find out dy over dx at that point, pi over 2, comma 2. Because that's where that's the point under consideration, isn't it? Alright, so x and y. X is 1, y is whatever you want to say right there. We already have it before us. This is equal to Okay, so let's see. 2 times cosine of pi over 2 over 4 times 2 minus sine pi over 2. Alright, that's what you got to do to show, okay, is this 0? Well, cosine pi over 2, what is it? You got to be able to, I like to look at the graph of cosine, because right here is pi over 2. This is the cosine graph. It comes up like, you know, does all that stuff there. Alright, so y is equal to cosine pi over 2, which is, by the way, 0. Alright, so this is 2 times 0. So we know that the numerator is 0, right? Okay. I hope this doesn't take super long, but I'm going to try this again. Here we go with sine. It's going to do this right here, isn't it? Come up right here. Something like that. And this, by the way, is, you guessed it, it's pi over 2. So y is equal to sine pi over 2. By the way, that is associated with 1. Alright, so 8 minus 1 is 7. So 0 over 7 is 0. So the first question we need to answer, do we even have a max, a relative max, or a relative min? Well, we have 0. That means we have a critical point, don't we? And it's 0. So we do have a slope of 0 at 2 comma, or pi over 2 comma 2. So there it is right there. That's what we did. So we have one or the other. Now if you want to flip a coin and say, okay, heads it's going to be a relative max, tails it's going to be a relative min, we can do that, but we can also prove it. Let's do the latter. Let's prove it. Okay. We do have a max or a min. So yes, we have a max or a min. Okay, now, which one is it? What other way can we determine whether we have this concave up and concave down? Because remember, if this thing is concave up, alright, the slope of this slope of this, which is what the second derivative, all that's it, the second derivative is, okay, it's going to be positive, it's going to be a min, okay, a minimum, even though, I mean, it's opening upwards, so it's got to have a minimum. Slope is 0 here, alright, or it's going to turn this way, it's going to be concave down, which means you're going to have a maximum, which we just pointed out a while ago. There's your max right there. Alright. And then of course here is your min. And I'm abbreviating this as a relative min and a relative max. Okay. We're not really concerned about an absolute max or an absolute min in this problem here. Alright, so let's go ahead and try to find this. Now, bear in mind, one thing that's nice is that dy over dx is 0. We do not have to copy this down when we're taking the derivative. All we need is just this. And then in place of this, what are we going to put? 0, right? Okay, now remember, this is a fraction, so this is a quotient rule. Yeah, let me erase this because we're going to need all the room we can muster. We know that dy over dx is equal to 0. Let's put that over here on the side. Alright, dy over dx is equal to 0. Okay, here we go. Now, we need this. d2y over dx. That's the way that's written, isn't it? I think so. Maybe it's written like this. I don't know. That's how I wrote these things out. I think that's it right there. That's it. Okay, now. That's the second derivative, in other words. Alright, so here we have low d high. Alright, so in other words, we're saying, I always say when you bring this up, don't do anything to it again. Don't turn around and take the derivative of this. I know y'all say low d high minus high d low over low squared. Okay, fine. But if you bring this denominator up, don't take the derivative of it once you bring it up. You've already made a move. It's like a chess move. You can't make two chess moves on your turn. You make one at a time. So here's your first chess move. There's your low. Let's bring it up here. So there's your bringing up. There's your low right there. Don't do anything to it. You just brought it up. The derivative of the high is the product rule. Okay, so I'm going to need some room here. The first, or let's say the derivative of the first, which is actually the derivative of y is 1. But that's really, remember when you take the derivative of y, you have an implicit differentiation here. So you got to tack on that dy over dx, which by the way is 0. Alright. The derivative of the first times the second plus, alright, on the product rule is plus, the derivative of the second, which is a negative sign, times the first. Now that's just this right here. That's just taking this derivative here. Now remember, you still got a minus sign in all this, so, oh my goodness, minus, let's just go ahead and put the minus right here. Alright, low d high minus high, so just copy this, times the derivative of this, d low, which is all this down here. So derivative of 4y is, remember, 4 times 1, which is 4. But remember, when you differentiate y, you tack on the dy over dx. Alright? Minus, this is not a product rule, it's just one after another, isn't it? Derivative of sine is cosine x right there. So low d high minus high d low, what's left? All over low squared, huh? So the low is right there. And we're going to square all of that. That's important that you remember to square the denominator. Let me make sure everything is in order. Alright. Okay. Alright. It's just so meticulous. You have to be extra careful here. Alright, so let's see now. Let's start looking at this now. Now that I have my derivative here, I'm going to start plugging in d2y over, and we're going to start plugging in pi over 2. We're going to start doing that. Woo! Okay. I don't know. We're going to have to see what we get here. Alright, so right here. 4. Oh, I don't know. We may just have to flip it back and forth. Let's see. Maybe we can... Okay, maybe we can put it right here. Okay, I'm just going to divide that up. Let's start up here and then we'll work our way down. Okay, so 4 times 2 minus sine pi over 2 . Alright, now this is 0. Remember, dy over dx is 0. That's the one good part about it. Cosine x minus plus negative is minus, so minus sine, well, let's put the y in front, 2 sine pi over 2. Woo, man. Alright. Minus, alright, 2 cosine pi over 2 times 4 times 0 minus cosine pi over 2 all over 4 times 2 minus sine pi over 2, all of that is squared. Okay, bear with me. 4 times 2 is 8. Sine pi over 2 is 1. So 8 minus 1. So 7 right here. Let's turn this over. Oh man. Oh man. Alright, so what we have here is 7. We're going to keep going back and forth. I don't remember what all it is. Well, I do have it right here. Okay. Alright, 7 times 0 minus 2 times 1 is 2. Minus 2 times 0, 2 times 0, times 0 minus 0. Alright, all over 7 squared, which is 49. Okay, now, right here, let's go back and look at everything. I do believe we have it. This is it. But now let's see where we got all these numbers from right here. Okay, so let's see. Let's go back. This is 7. Cosine, it should be a pi over 2 right here. Pi over 2 is 0, so 0 times 0 is 0. 2 times sine pi over 2 is 2 times 1 is 2. So minus 2 times 1. Alright. And then this is cosine pi over 2. We know this is 0. 0 times all of this is 0 in it. So this is actually 0 minus cosine pi over 2 is 0. So in parentheses, that's that. So 0 times all that. And this is 7. 7 minus, I'm sorry, 8. 4 times 2 is 8. It's all 7. 8 minus 1 squared, like that. Okay, there it is. Sorry about that, going back and forth like this. So now this is actually going to be, the top is going to be 7 times negative 2 minus 0. All of this is 0. All over 49, which is negative 14 over 49. You can leave it like that. Now that's really all you want is the sign right here. That's all you were looking for, is that sign. The sign, if it's negative, that's taking that second derivative. Now we know that f is concave down, which means, or implies, therefore f has a, now remember, if it's concave down, that means that d to y over dx squared is less than 0. Okay, the second derivative. Alright, so f has a relative. Now, you know what the temptation is. This is negative. Well, it's going to be a min. No, you got to remember, if this is negative, that just means the concavity is down. Don't say this is a min here. This is the second derivative. This is just showing concavity. So since this is concave down, we have a max at this point, which, what is that point? Pi over 2, comma 2. So has a relative max at the point pi over 2, comma 2. That's it. So what you need to recognize in this video, if I had to give a title to this video, is interpretation of the first and second derivative relative to maxes and mins. So first of all, we had to figure out, do we even have a max, a relative max, or a relative min? So when we found that this first derivative was equal to 0, which we found out just at the beginning of this lesson, then we said, okay, now we have a max or a min. Now is the concavity upward or downward? So when we did all of this stuff and plugged in the numbers, okay, we did this right here, and we got down to negative 14 over 49, which, by the way, please don't reduce it incorrectly. If you want to, you can say negative 2 over 7, and therefore f is concave down, because the second derivative is negative, and therefore f has a relative max at pi over 2, comma 2. That's important that you understand all this. It's a beautiful problem. I love this problem here. If you want to learn how to do maxes and mins, this is the perfect problem to pick right here. Part D of number 5, 2021, number 5, part D. Yeah. This is, of course, you got to know how to do part C, which I did in my last video. So if you want to watch that video, you're welcome to do that. But here it is right here. Very nice. This is KP the Math G, getting ready to sign off with that signature clap that I always do. But before I do that, please subscribe if you haven't done so already. It would be nice if you hit that like button. You know, I always say this, but I smile when I even talk about that like button. Comment if you'd like to. That would be alright if you'd like to do that. But then again, this is not for me. Well, it's to keep my mind sharp. A 64-year-old mind sharp. Yeah. And I love doing this anyway. And it's for you, though. This is for your benefit. So if you were confused about that first derivative and what it means, and the second derivative, what it means, don't be confused anymore. You have it. Okay? Relative min, relative max, first derivative. Concave up, concave down, second derivative. There you go. Concave down, max, concave up, min. There you go. You have it. Alright. This is KP the Math G signing off. Ladies and gentlemen, have a great, great day. Oh, I want to do that again. Alright? Have a great, great day. Ah, yeah, so much better. That even burned a little bit. So good.